in miles, so you can.
हेलो। हाँ, गुड मॉर्निंग, गुड मॉर्निंग। लॉगिन हो गया मेरा। हाँ हाँ, ठीक है, मैं भी ज्वाइन कर दूँ। Hi, good morning, everybody.
Good morning,
Good
sir.
morning, sir.
Good morning, sir.
How's life? How's it going?
All good, sir. I cleared my function 3 Fridays.
Oh, excellent, excellent. Congrats.
Thank you, sir. Thank you.
How was the experience? Can you share some experience on
Yes,
a
sir.
Sunday morning?
Actually, this they asked me regarding this latest the CEXI, CII, the SIM part 3. They asked to
Okay.
explain about CII, and I explained about the EXI.
Okay.
Then this goal-based standards, they asked me, I explained it about them.
Okay.
And then this our life this this sorry sir, I forgot this our this pressure test, what annual test we do on this immersion suit. They asked, I explained it about that with a dummy, this fill air of 1.4 kilopascal and check for any leaks. I explained about it to them.
Yeah.
And then they asked me about this why bow flare. They don't ask what bow flare is. Why bulk carrier should have bow flare.
What layer?
Bow flare in the bulk carrier.
Okay. Okay.
So then I told them about this because of the green seas, the load that hatches should carry about that 1.8 kilonewtons. I explained it about them.
Yeah. Yeah.
And then they asked me about what is tonnage deck.
Tonnage data.
Tonnage deck.
Tonnage deck. Okay.
I explained it, and they asked me around 9 to 10 questions. Only one I did not answer, in the sense he asked me what is the empty CO2 bottle regulation. I told him it has to be pressure tested for either 55 bar or 2.7 times the working pressure. Then he asked me more, what else you have to do. I told, sir, I know only these in SOLAS also it is given the same thing, I told. But he's telling this as ISO standards, this empty CO2 bottles have to have some more things except this hydrostatic testing. Few other things are there. He told. I remember only. I know only this point. I told him. Then he did not tell anything. He told some few more points are there. I did not answer him. I only answered him. This rest all. Whatever he asked, I almost answered, sir. So
the question regarding this ISO standards, that was for the CO2 bottle?
Yes, empty CO2 bottles in the store before refilling, what they do. What all the checks they do.
Okay.
That I could not. I knew only this point, so I could not answer. So rest all I answered, and he asked me about my written results. I told I've cleared everything except for naval.
Yeah.
Then they told I've cleared function 3.
Okay. Now you are left with function
4B and 6. Sir. Last month I gave in November, but they did not give. They just asked me like first time you are giving. I told yes. That time my written results was also pending. They asked me only few questions. They asked me about the ignition delay. I explained it to them. Then they asked about what type of engine I said. I told about RT-Flex. So he asked me, do you have V18 RT-Flex? I told physically we don't have, but yeah, the what all the functions V80 does, this RT-Flex engine does, I told him.
Yeah.
Then he asked me about Super V80. I explained about that the VIT, which this the plunger, the VIT ignition as the injection can be delayed with the movement of the plunger. I explained about him about that.
Yeah,
He
yeah.
told me that is VIT. He is asking about the super VIT which came after that. I told him that I've never worked with VIT. So what I told him is that I saw one video about VIT and Super VIT from on Chief Engineer on YouTube. So I explained him that
Uh,
VIT is the one which came early, in which this Sulzer engine, RTA Sulzer had with that this flyweight adjustment. I told him about that, and Super VIT I told about this MAN engines, what they had this plunger adjustment. But he told there is one more thing that the Super VIT you have to explain that. I do not know that. Then
yeah.
he asked me about what type of air cooler you have in main engine. I told this plate type air coolers, and he asked me the reason. I could not tell.
Hmm.
Then 4B he did not ask much. Then after function 6, he asked me this boiler safety valve. What is the how you do the safety valve setting? He asked me.
Yeah.
I told him the procedure, like initially, like we have to not tighten it much. So initially we have to bring up the pressure and see at what pressure it is lifting, and after that we have to depressurize it and adjust the setting. So one by one we have to do one safety valve, we have to gauge it, and the one we have to do on the other one, like one by one. I told him, and
Right.
he asked me only 2 questions, but I was not in the mood to give, maybe because my written results was not out and something I don't know. So he told come again next time.
Okay. Okay. But what I can see,
Yes, sir.
the questions that are asked, right?
Yes, sir.
He's not going into depth.
Yes, sir.
He's just trying to see that if you know what it actually means.
Yes, sir.
So that is what I can see. Because see, he asked you EXI, CII,
Yes,
then
sir.
coming to the VIT part, he did not dig as to you know how
Yes, sir.
exactly the mechanism is, but he wanted to know if you know what is super VIT.
Yes,
So
sir.
he's not trying to dig into it. He's trying to go on the top and just that if you know the criteria and if you know the fundamentals.
Yes, sir. Yes, sir.
So that is what he's trying to do.
Yes, sir.
So from all the questions, I can make out that only.
Yes, sir.
If you know the fundamentals, it should be good enough for him.
Yes, sir. Yes, sir.
Okay. But yeah, just to put this question to the class, I mean, today we are on the propeller part. But before we start with propeller, anybody wants to answer what is this super VIT? Ganesh, Mahindra, Satish, do you want to answer?
Sir, VIT that break point is fixed, sir. But in Super VIT, we can change the break point, sir.
That is right. Basically, Arvind, um, in
I
your
explained him
VIT,
about this break point and all. I explained him. He's telling that is in VIT, that is not super VIT. He told him.
no, see,
Yes, sir.
VIT and super VIT are both things,
Yes, sir.
but what you should have said that
Yes,
the band of the VIT can be varied,
yes,
the
sir.
band of the VIT.
VIT. Okay.
So that is what he is expecting. So when you say band of the VIT, let's
Yes,
say
sir.
VIT at what you might have studied that VIT starts at 40% load,
Yes, sir.
correct?
Yes, sir.
40% or 50% load, that is what is adjusted by the maker. When I say break point,
Yes, sir.
then the break point might be 80%, 85%, correct?
Yes, sir.
But what happens in super VIT, you can adjust that band, okay?
Yes, sir.
Uh, let's say VIT starts at 40, 50%, you can bring it down to 10%.
10%. Yes, sir. Okay.
You can make it happen at 10% and
10%.
then continue all the way to 85% to, get a better fuel efficiency.
Yes, sir. Okay. Understood. Yes, sir. So this adjustment of band, yes, sir.
Yeah, adjustment of bands. And you can vary. And how do you vary? Normally, when the super VIP came, it came with a IP converter.
IP converter.
Okay.
Okay.
And then there is a cabinet. That cabinet's name is EGS 2000. Okay.
Okay, sir.
From that EGS 2000, you can actually, there is a screen also, and you can actually give a command. Where do you want to start your VIT? Okay, at what engine load? Okay,
Yes,
and
sir.
what is the P offset that you have to enter? What is P offset? So as per the shop trial model, right?
Yes, sir.
The maker says, okay, at 10% engine load, this should be the P max. At 20% load, this should be the P max of the engine. At 30% load, okay, this should be the P max of the engine. So what do? You see that your P max is not matching. Let's say your engine is running at 30% or 20%, and you see that the P max is not matching. So the shop trial data, as per the maker, it should be, let's say, 100 bar, and you are at 80 bar. What is the difference? 20 bar.
20 hours,
And
sir.
that is the 20 bar is the P offset value that you should enter in EGS 2000.
2000.
So, yeah, so that 20 bar error, that is the 20 bar P offset, the signal is given to the VIT racks, and the VIT will adjust according to that to bring your P max very close to your shop test value. Okay.
Yes, sir. Understood. Yes, sir.
So basically, you can start of uh, start of VIT, end of VIT, you can control everything, right?
Yes, sir.
So that is the idea. VIT itself is only a basic fundamental, but super VIT is something like an action.
Action. Okay, sir.
Yeah. Okay. Ganesh, hi, and Mahendra, I see you for the first time. Are you the new candidates?
No, sir, I have been there, but actually, last month my role was different, safety and
Okay.
electrical. So now I joined that.
Okay, that's excellent. Yeah. How about you, Ganesh? Hi, Ganesh.
Hello, sir.
Hi, hi.
Hel-
You just joined the class, or?
No, sir. I have actually I'm applied for 2 years before, so just 1 month before I signed up, sir. So that's why, sir,
Okay,
just joined today, sir.
okay, okay. No worries. So you were in the AIMS class 2 years before.
Yes, sir. Yes, sir.
Okay, okay.
Yes, sir.
But you discontinued and started sailing and then just joined.
Yes, sir. I was discontinued, and after that now I started it.
Okay, no worries. Entering the pipeline is more important. You will get on the other side somewhere. Okay,
And
no worries. So
yes, sir.
yeah, yeah. Arvind, hi. You
Yes,
were
sir.
saying
Sorry.
something?
He asked me one more thing that I think regarding this function three. This he told me this ISM element 10 is maintenance of ship and equipment. So how will you ensure that it is implemented?
Okay.
Then I told him about this critical score, and for a machinery, we'll calculate critical score, failure, severity of failure, and all. Then he asked me how will
Yeah,
you calculate and all. I just told him that failure probability of a machinery will depend upon will take like 2 to 3 things. For example, if your mooring winch is there, so depending upon its
yeah,
exposure, its use and reliability, so we'll calculate this failure probability, and the severity of
yeah.
failure also, how it is impacting the human environment and all. As per that critical score we'll see, and as per that we'll decide if it is that critical score is there, so we'll assign it under the critical equipment, and it depends upon the company to company, I told him. Then after this he was like, okay.
Okay.
Okay, sir.
Uh, I think we should have added something more to it.
Yes, sir. Which point, sir?
Okay, we'll discuss. We'll discuss.
Okay, okay, yeah, okay, sir. Okay.
Meanwhile, what I will do, I will try to share my screen. Okay, before I share my screen, I would like to just, um, update the class who have not attended the previous class. So we started with the topic of dry docking. Okay, dry docking of ships. And before that, we were doing a different topic. What was the topic, Arvind, if you remember? Satish?
Week I did attend only one class. It was about stern tube. I think
Yeah,
last
yeah.
yes, stern tube. Yes, one class I attended because I was busy with this function 3 preparing. I did not attend for last 2 3 weeks.
Okay, okay.
Okay,
So
sir.
I think you're right. We were doing with the stern tube, which
Yes,
was
sir.
also a part of the dry docking later on.
Yes, sir.
But stern tube come materials just for Mahendra and Ganesh. I have already sent it in the 4B and 6 group. Okay. If you do not understand something, let me know. Okay. So we
Okay,
can
sir.
work on it. Uh,
Okay, sir.
uh, Now what we are going to see is that see the types of dry dock and the purpose of dry dock, the regulations of dry dock, we have already covered in the previous class. For that also I've sent the material. Okay. So I before shooting into the dry dock, I just want you to understand that we have a process. So understand the process, how we are proceeding. Otherwise, if you start studying everything, you will never complete it. Okay. So first we started with stern tube. Next we went on to the regulations of the dry dock. Okay. Why a dry dock is required and who will do it and what is the importance and so on. The types of dry dock we have seen and which is beneficial, which is not. There is one presentation that I sent of how we do the dry dock, what details are considered, what is the repair job list, how and how do we prepare it. उसका सारा मटेरियल भेजा हुआ है, वो आप एक बार खोल के देख लो, ठीक है. But if you do not understand that, let me know, ठीक है. Separately I can answer these questions. We'll take it outside this forum. Is that fine?
Okay, sir.
Yeah. And now we will look into the propeller. Okay. So before jumping into propeller, I would like to brush up on few fundamentals. Um, what kind of stresses did you have you known? What kind of stresses have you known in the propeller or in any material? Let's say.
Tensile stress,
Hmm. Okay.
compression stress, and this torsional stress, torsional vibration, torsional stress.
Yeah.
And in propeller, maybe due to cavitation, there will be and the since the location of propeller it is very close to the hull, and this hull induced vibration is also will be there in the propeller.
Right.
Fatigue also, sir.
Once again,
Fatigue also, fatigue.
fatigue stress. Yeah. But having said all done, um, is there a name to all this stress? Do we have a certain name? Acha, fatigue hai, compressive stress hai, no, expansion and so on. Yes. But is there somebody who has discovered names of this particular stress?
I don't understand the question, sir. These are the names only, no? Fatigue, stress, and all.
Yeah. See, fatigue is a phenomena, correct?
Yes, sir.
But has anybody discovered what? I mean, what is the exact name of the stress which happens to the materials? I'll just give you a clue. There is something called a yield stress. Have you known that?
Yes, sir. As per elasticity of the modulus of elasticity and yieldness, they'll check.
Right. So there is also shear stress,
Yes, sir.
right? So looking in a broader version, right, we will have shear stress, yield stress, and all these things. Which stresses do you think? Okay, Ganesh and Mahendra, the rule of the class is that you can open your mouth and speak anything that you want. ठीक है यहाँ पे कोई restriction नहीं है.
Okay, sir.
The more you speak, the more you get better. Yeah.
Okay, sir.
Yes, sir.
So you have
Yes.
to be a speaker. If you just look at the screen and listen to me, either you will go to sleep or oral में सारा doubts आ जाएगा. So you make mistakes here, as many as you can, and then we will come to know what mistakes you are making, and then finally, those can be corrected. And speaking will also give you some confidence, so you don't go and stay quiet in the panic room.
Okay, sir.
Okay, so um, everywhere, you can find strength of material mein, website mein, everywhere, that okay, these are the stresses, yield stress, shear stress, bending stress, tensile stress, and so on. So basically there is stress. So what happens when you apply a stress to anything? Just try to think what will happen.
It tries to change the shape.
It tries to change the shape. So what is this change of shape called?
Strain.
Strain. Correct. So stress by strain, when I say, okay, this is the stress that you applied and this is the strain that has happened. Okay. So what am I trying to calculate?
Some modulus that is called.
Young's modulus, I think.
Yes, it is called Young's modulus. That is right. So there was one fellow who invented that, okay, this is the stress. Okay. And somebody said, okay, if I apply this stress, so this is the strain which is going to happen. Now the strain will happen in any dimension. Okay. So when I say dimension, it means length, breadth, area, anything can change. It depends on how and where the stress is applied and under what conditions it is applied. So let's say what I'm referring to, what I'm coming to say is that if you have a propeller, okay, and you are going to fix it, right? So where is the propeller fixed? Anybody?
Sir, you're not audible.
Okay, how is it now? Is it audible?
Oh, yes, sir. Now it's okay. Yeah.
Okay, relating to the propeller, where is the propeller fixed? What is the exact location?
The aft end of the shaft.
Aft end of the shaft. And without looking at any diagram, can you tell me, can you describe how the aft end of the shaft looks?
Sir,
Slightly sloped. The aft end is slightly sloped to accommodate the stern tube.
Once again.
Yes, sir.
Can you explain once again?
Yes, sir. The aft end is slightly sloped.
Okay,
The
so
aft
there
end
is a taper.
taper. Yes, sir. Sorry, yeah, taper.
The aft end is a tapered.
Tapered. Yes, sir.
Okay. And
The aft end is tapered, and before taper there is a chrome liner. On the chrome liner there is a seal, and after that the chrome liner is bolted to the hub of the propeller, and then the propeller is bolted there.
okay. And what about the propeller? How does it look like? See, I'm not sharing or projecting anything on my screen, because as soon as I project, then you will have that idea only. Okay, it looks like this.
It looks
But
like a
I want to get the answer out of you and then project it.
cantilever. A lever which is having a load on one end.
Okay, correct. Just hold on. Hello? 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 हाँ, मैंने एडमिट किया है। नहीं नहीं, मैं एडमिट कर दिया हूँ ऑलरेडी। क्या है कैंडिडेट का नाम? ठीक ठीक, फाइन फाइन, नो वरीज। Okay, so somebody else is also joining. So the aft end of the shaft is basically tapered. Into that tapered shaft, you have your propeller which is fitted. Now, if the shaft is tapered, aft end of the shaft is tapered, what is the shape of the propeller exactly? Can you imagine? What is the shape of the propeller boss where the tapered shaft is fitted?
Cylindrical or round, if we see from
Angular.
the
Conical, sir.
Conical, exactly. So when the shaft is tapered, the propeller boss has to be conical. Now this conical part of the propeller has to go and fit on the tapered shaft, correct?
yes.
Yes, sir.
So when that happens, I will tell you a very interesting funda, which is also a part of your exam. Okay. Uh, though you don't need to study that in detail, I will project that. So, hold on. Just trying to find something. And one more candidate has to join. Somebody else has joined. Is that Ankit Singh who has joined new?
अभी ज्वाइन कर रहा है सर वो कैंडिडेट अभी
अच्छा अच्छा, ओके, ठीक है ठीक है।
बता रहा है
ओके, सो लेट्स कंटिन्यू, लेट्स नॉट वेट। तो क्या है कि देयर व्हेन आई सेड कि all these things are when the tapered shaft is fitted onto the propeller boss, which is also conical, ठीक है? So what happens that there are number of stresses which are introduced as per your exam point of view. This is important to know that uh, all types of stresses start acting on that tapered shaft. Okay, we will get into detail what is that stress, but just understand that all types of stresses, okay, whether it is induced by a temperature or it is induced by a pressure or it is induced by friction, all types of stresses, okay, they start acting on this propeller boss. That is why fitting the propeller and removing the propeller becomes really a important procedure. Though the procedure is very easy, it is just like putting a jack and pulling it out, and using a jack and pushing it in. But how to pull that out, and how to what are the checkpoints, that is what will be asked in your exam. Okay. So let me share my screen now. Okay. What is this now? Can you see my screen?
So stresses.
Yes, sir. Yes,
Yes,
sir.
sir. Yes, sir. Yeah.
Okay. So there are stresses, and these are the types of stresses which you already have mentioned and seen. So there is compressive, tensile, stretch, shear, torsion, bending, right? All these types of stresses. Now, every stress will try to deform your material, that we have already known. Okay. Hold on. Just getting a call. Just give me a minute, guys. Okay. So I'm back. Yeah. So ये सब जो stress था, these are the stress, but you can see all the stresses are in a different direction. Okay. So some are in the compressive direction, tension direction. Shear is trying to shear it. The torsion is trying to twist it. The bending is trying to hog it or sag it. Right. So that becomes the types of stresses. But in a propeller, when you try to fix this propeller and run this propeller, right? So the stress is basically acting in all directions, right? In all the planes, X, Y, Z, all planes, right? Do you agree?
Yes, sir.
Yes, sir.
So when you have a three-dimensional plane and all the stress acting in all the directions, right? So this kind of stress is basically called a von Mises stress. Now I will show you. It is called this guy. This guy's name is von Mises. Okay. So what he is trying to do, whenever there is a stress, there is a strain. Definitely. Okay. So you can see this is an extract of von Mises
Sir,
theory.
sorry, your voice is not clear, sir.
How about now?
Now it's okay, sir.
Now it's okay.
Okay. So there was a guy. His name was von Mises, and then he invented that whenever the component, okay, uh, is subjected to a multi-directional loading, okay, how to calculate the strain in that. And by calculating the strain, he's trying to calculate when this material will fail. Okay, so that is the idea behind this, idea behind the von Mises stress. So when you are looking into this particular direction, this one, uh, compression, tension, shear, torsion, bending, so you can see all the stresses are in one particular direction. Correct? They are defined. Compression is trying to compress it. So both the arrows are pointing towards the material. Tension is trying to, you can see my screen, right?
Yes, sir. Yeah,
Yes, sir.
can see, sir.
When I'm switching the pages, you can still see it, right?
Yes, sir. We can see.
Yeah, yeah. So all this stresses, the arrow, you look at the arrow. So it is basically the axial stresses, which is defined here. And you can see it is one type of stress. It is individually shown here. But one Mises stress, a number of stresses will be shown together, right? And with that formula, you can actually calculate the uh, strain and how much strain it can take and when it is going to fail. So that is what is applied to the propeller also. Though you don't need to know the how to calculate the von Mises stress in a propeller, but you should know the word. Okay, you should know how what is being calculated. So whenever a component, you can see it is mentioned here, it is subjected to biaxial or triaxial loading. Okay, it undergoes a failure with the maximum distortion energy unit per volume in the object reaches to the yielding distortion. Okay, so what he is trying to say, whenever there is one or two more stresses which is being applied, let's say there is when you fit the propeller, right, onto the cone. I will try to explain. Hold on, I'll take a whiteboard, because before starting the propeller theory, to know this is very important. Otherwise propeller का gist ही miss हो जाएगा. Okay, so this is the shaft and this is the propeller. So and this is the taper. Okay, that is the taper. So you're trying to force the propeller boss onto the taper. So what will happen to the propeller boss? Will it expand? Yes. Correct, na? Do you think it will expand or contract?
Expand, sir.
This is the propeller boss. Okay. Here is the propeller which is fitted. And you can see this is the taper and this is the internal of the boss. So when you try to force it onto the taper, so the boss itself is trying to expand, right? Because when I say boss, then it is like this. This is the propeller, right? And this is where the shaft is going to go and fit. So this thing is going to expand, and when that expands, that is a stress which is applied to a conical surface. So some parts will be, under compression, some parts will be under tension, some parts will be under shear stress. So you don't know which stress is where. So the stress is acting from all the direction. So that is why I mentioned this von Mises stress, right? So what the von Mises stress will do? It will create a strain in all the direction, right? And the strain will be created until the unit fails. But our idea is not that the unit should fail. We should calculate a safe strain that the propeller boss can take. That is the idea. Okay. Is that understood?
Yes, sir. But how the strain is created, sir? One message.
The strain is created by applying the stress because as we discussed, yahan pe, whiteboard. If you can see, I am going to force the propeller onto the boss by jack. If you apply a jack here, then I am going to force it onto the propeller. Now, the idea is you can force it and you can fix a locking nut here. Okay. But I should know, right, how much I can force it. If I force it too much, the cone will crack. Correct?
Sir, yeah.
Is that understood to everybody?
Yes, sir. Yes, sir. Understood.
Yes. So if I force it too much, then the cone will crack. So you should know how much you should force. Correct? If you
Yes.
force it less, then what will happen?
It will not fix
Propeller will slip.
on same on position.
It will not fit
So,
properly.
okay. So what is missing if it is not fixed properly?
The friction force.
The bedding, basically. Right?
Yes, sir. Bedding.
So the contact surface will be missing if I don't force it properly. Yes? But if I force it too much, then it will
Sir,
be
your
leading
voice
to
is not
cracks.
clear, sir.
So what I was saying, if you don't force it, then the contact surface will be missing. If you force it too much, there will be crack. Do you get it?
Yes.
Now you can feel the importance of, calculating how much stress to apply. So your propeller boss is not exposed to, harmful stress, so that it will go and so you should exactly know which stress are you facing. Only then you will be able to calculate कि मुझे कौन सा what stress I am dealing with, right? Only then you will be right. So that is why.
Sir, again, your voice is not audible, sir. Sorry.
Hold on. Okay. Now.
Yes, sir, but the volume is very low.
Okay. Hold on. Is it better now or
Yes, sir. Now, okay, sir. Yes, sir.
okay? I don't know. Something is happening to my laptop or is it Zoom? I can't imagine. All right. So that is the importance of calculating the stress. And this particular stress is called the von Mises stress. That it is going to act in all the directions. This push direction, then the conical direction. Okay. Then there is going to be a reaction from here. You see how many directions? So it is going to act in all the planes. So that is why we are calculating the von Mises stress. Now, as an engineer on board, you don't have to go and take a pen and paper and calculate the von Mises stress. It has already been calculated and defined and the graph is formed. Okay. So the graph is already there and you just have to go and verify the values. But where is the graph and what values you should verify? That is not known to many people. Okay. Because it is not a daily thing that we deal with. I will show you. Hmm, I have something. Okay, now this is the propeller manual. Okay, can you see?
Yes, sir.
Okay, so this is the maker manual itself. This is from Mitsubishi Heavy Industry, MHI. So in this particular manual, they have specifically defined of what is the tolerance of the push that you should provide to the propeller. How much push you can give. Okay. Now I will show you. I will directly take you there. Can you see?
Yes, sir.
Yes, sir.
Okay. So this is the diagram, and let's know the components. What are the components? So this is basically a hydraulic pump, producing the hydraulic pressure. See, we are not going to see, we have not yet seen how the propeller is removed or fixed. We are only seeing what is the stress and how you can avoid it. With this as a fundamental, I will proceed into the propeller topic. Without this, I don't want to proceed because there will be many questions will be unanswered. Why am I doing like this? Okay, right. So this is the basis of all fundamentals. And if you have this fundamental ready, you can decide by yourself whether the procedure that you are going to carry out, will it affect the propeller. Okay. So that is why this is the basic that I'm taking. After this, we will go into, removing propeller, putting propeller, repairing propeller, because all those are very easy topics. This is important to understand. So this is your hydraulic pump. This is your pressure gauge. It will show you the hydraulic pressure. This is the valve block. Okay. This is the valve block. So you can see one connection is going to this port and the other connection is going to this port. What is this? This is the jack. Okay. So the hydraulic oil goes here, and then this is the loading ring of the jack. So this will push the loading ring. The loading ring will push the propeller, and thus the propeller will be pushed onto the shaft. This is the shaft, correct? Do you understand?
Yes, sir.
Is everybody with me?
Yes,
Yes,
sir.
sir. Yeah, sir.
Yes,
If
sir.
anybody wants to repeat, then always interrupt me, stop the class and interrupt. Okay. So what is happening? This is this hydraulic pressure which is being applied that pushes the loading ring, which is here on the jack, and that loading ring will push the propeller boss. So, the propeller is right here. They have not drawn the blades, but the blades are somewhere like this. Okay. These are the blades of the propeller. And you can see this is the shaft. Onto the shaft, what are these? These lines. ये सब क्या है?
वो hydraulic pressure exert करने के लिए for expansion.
So basically, there are very fine grooves. Okay. There are very, very fine grooves on your propeller shaft, boss, internals, right? Why this groove is provided is to have the flow of hydraulic oil. Only then the hydraulic oil will go and it will try to, it will seep inside between the clearance between the shaft and the propeller boss. And then when you apply a pressure, it will try to expand the boss. So the clearance is created, and either with that clearance, you can push or pull the propeller. Is that okay? Understood?
Yes, sir.
Okay. So
Yes.
that is why that clearance is very, and it is not like a deep groove. You can't even feel this clearance. If you put your hands there, probably, you will hardly feel it. That is the amount of groove that is provided. And another interesting thing to note is that you have a dial gauge which is placed over here. Okay. What is the dial gauge measuring? It is measuring the travel of the boss. So when I say you should limit your push while fitting the propeller, how do you limit that push if you don't know how much the propeller has traveled, correct? So that is why you should have a dial gauge. Is that understood?
Yes, sir.
Yes, sir.
So what am I going to achieve with this dial gauge? I will show you. So we have studied the components. Did I go wrong anywhere? Let me see myself. Okay. Yeah, most of the things I have mentioned here. So the dial gauge, propeller, shaft, this is that jack, and pump and valve block. Yeah, okay, fine. Acha. Hmm. Okay, now you see this is a graph. So what is this graph? This is a graph which the maker has already decided. The propeller maker, he has given it to you. Okay. So this is the graph versus push-up travel versus the temperature of the propeller boss. Okay. And he says this is the push-up travel which is required for this particular propeller. Okay. So he has provided this particular graph. So if your temperature is 40 degrees Celsius, okay, if your temperature is 40 degrees Celsius, that means the shaft will be, this should be your push-up travel. That is what he means. Okay. So you should push it to, let's say, 20 mm. If your temperature of the propeller is somewhere, let's say, 0, then you should be pushing up to about, let's say, 24 mm. So he has given basically a temperature related graph of the push-up travel that you should apply. It is simple to follow, right? You don't have to calculate any stress or strain or something like that. You can simply look at this graph and you can try to follow this. Is it simple enough?
So this
Sir,
is total
here,
push or this
uh,
is a dry push?
Once again,
uh,
This one is total push we have to make or only the dry push?
see whether it is a dry push or a wet push, your contact surface has to be at least 90% matching, right? To
Yes.
match that, the stress will be the same. The strain produced will be the same, correct?
yeah, sir, so temperature will be more, then push-up will be more, no, sir? So distance will be more.
It depends. See, for this particular propeller, you can see यहाँ पे push-up travel है and यहाँ पे push-up load है. ठीक है? So you can see by this graph, जितना travel ज़्यादा होता है, the load is increasing, correct? Can you see in this graph? On my x-axis, this is the push-up travel. That means this is the length you should be pushing up in mm. So 0 mm to 28 mm is the range here. And this is the load. When I say load, what is that load? That is the hydraulic pressure that you should apply. Correct? Do you understand this graph?
Yes, sir.
So if the
s-
distance
excuse me, sir.
increases, the load increases. हाँ बोलो बोलो.
सर पुशअप ट्रैवल जो टेम्परेचर, अगर टेम्परेचर ज्यादा रहेगा तो पुशअप ट्रैवल विल बी मोर ना सर, जो ऊपर वाले ग्राफ में दिखा
Why
है
it
सर.
will? But why it will be more?
Because temperature will be more, then it will be expand, that boss will expand and it will travel more.
Why do you think it should travel more? This is very interesting question. I will really like the. Uh, okay, let's discuss this. Okay, इसको मैं क्लियर करता हूँ. अभी एक propeller shaft में बनाता हूँ. Just the aft part only. So let's say it is like this. This is the taper. Okay. So this is the taper. I am going to fix a propeller boss onto this. Let's say the temperature is too much. Okay. Let's say outside temperature is 40-45 degrees Celsius. So you said the propeller boss will expand more. Correct?
Yes sir, yes sir.
So it will, I agree to that. So if it will expand more, that means a cone which is like this, it will become like this. That is what you are saying, right? Correct?
Yes sir.
So when the cone has already expanded, it will simply go and fit there, no? Why do you need to push it up? So there is no travel. It will simply go and fit there. Okay. So the push-up distance that you have to provide is minimum. Okay. Now let's consider a case where the temperature is very low. Okay. So yours is like this. That means when you take this boss and fit it here, how will it look? It will look like something like this. It has not expanded because the temperature is 0. Okay. It will look like this, correct? That means this is the distance that you have to cover. I'm just exaggerating the drawing. It may not be like this, but that is the distance you need to cover. That means this is the push-up distance you need to provide, correct? So the push-up distance in a cold weather becomes more.
Okay sir.
Is that understood?
Understood sir, understood.
So that is why you will see in this particular graph, the temperature is more. You look at the push-up travel. That is, you have to provide minimum stress to go and fix this propeller boss, correct? Whereas the temperature is 0, right? Then you have to provide more travel, correct?
Yes sir.
Correspondingly, if the travel is more, you see, if the travel is more, if you have to provide 25 mm, then the load is also shooting high, correct? So the load is also shooting high. So if the travel is less, then the load is also less, correct now?
Yes, sir. You understood.
So basically, if somebody is asking you, okay, how to fit a propeller, so you will say, okay, I'll bring a propeller, hang it behind the shaft, and then I will use a jack. Then I have the pull-up method and the push-up method. You should not stop your answer just by saying that. What you should say is this particular graph. So there is a graph provided by the maker itself. Okay, and this particular manual is basically the you can call it as the loading graph, or the push up and pull out instructions for keyless propeller. That is what it says here, but what it provides is basically the loading instructions, okay, of how much to load. There is a pressure gauge which is given, right? The pressure is calibrated in terms of Newton per millimeter square. So you can decide, acha, this is the load that you have to provide. For that load, what is the corresponding pressure? So that is the pressure. When you apply the pressure, you should verify it by the travel of the dial gauge. So how do you measure the length, which was in mm? You measure it by the dial gauge. Okay, 0 mm push karna hai, 24 mm push karna hai, 15 mm push karna hai, whatever is there, that you can measure it from the dial gauge. How will you measure the load? The load can be measured from the pressure. How will you measure the temperature?
By a thermometer, temperature gun.
You can use a temperature gun. Okay, you can use a thermometer. Either ways. So this is important to know. All right. These two graphs, just remember it. In an exam, you don't have to draw the exact values, but if you can just draw the X and Y axis and label these two things and put a line across and say, okay, this is the temperature based relation and this is the load based relation. So temperature and load, both you have to show in a different graph. And then you can say, okay, if this is the temperature, will be the travel. According to the travel, you measure the load, and you see the load is calibrated in terms of kg per centimeter square, and then you can apply the pressure. Okay, so the problem is solved. That is it. Okay, now let's move to the propeller. This is understood, right?
Yes, sir.
Anybody remaining with any doubts? Mahindra?
Sir, there was push-up pressure or temperature, the last graph on this
Push-up.
y-axis.
See, both pressure and temperature both are defined. According to the temperature, you have to apply the pressure.
Okay, sir.
Okay. You are into this 4B and 6 group. You're already there. Is it?
Yes, sir. Yes, sir.
I will provide you this particular graph in the after the class. No, I will provide everything in this 4B and 6, whatever we discussed. So you don't need to note down anything, basically.
Okay, sir.
So with these fundamentals in mind, we will move ahead, and then I will share my screen again. Hold on. By the way, I forgot to wish everybody Christmas. Happy Christmas, guys. I just now.
Happy Christmas, sir.
Happy Christmas, sir.
Merry Christmas, sir.
How many you celebrating Christmas today?
Merry Christmas, sir.
Thanks, bye. Celebrating Christmas?
No, sir, no, never.
Why?
I've never celebrated Christmas. Maybe on board, yeah, but at home, never, sir.
For me, yeah, I celebrated with my friends and family, but with my parents, no, because they have not been celebrating Christmas for a long time. But friends and family, yeah.
Okay.
And I actually did not remember that it is Christmas today. I just came across a vessel visit, came back late in the night, and then, yeah, crashed to bed. So when a vessel is going to the dry dock, okay, what is the first thing that you do as an engineer? What do you think you should go and do?
So prepare dry dock specifications for the item to be rectified.
No, the vessel is already entered the dry dock.
So
We'll check the when the water is pumping out, nothing is coming out, and then we'll check also the propeller. We'll take the propeller drop.
If somebody is asking you a question like this, no, what is the first thing you will go and do? Slap on his face. Honestly, this is not a question to ask. The vessel has entered the dry dock. What is the first thing you will go and do? So that is not an appropriate question. And this is what the question that the MMD is asking you. I am totally against that. So if you get a question like this, I intentionally asked you this question, that if you get a question like this, you ask him in what terms. First thing I will do many first things. Okay. Well, the vessel has entered the dry dock. There are many things to be done, right? So you will not you will not go and start doing things by your own, because there are so many things and you don't know which to proceed. So what happens as soon as the vessel enters the dry dock, with all the precautions taken and everything done, right? When it is already sitting on the blocks, okay, there are some important things that you should be doing, but not immediately. Okay. So before any process starts, there is a meeting. There is a opening meeting by the dry dock. So you should wait for that opening meeting. In the opening meeting, there will be a dry dock representative, right? And he will basically give you the assigned contacts of different departments. So if there is a fire and safety department, the contact will be provided. If there is somebody to be called for technical glitches, then separate contact is there. If somebody is to be provided for shore power and other electrical issues, then a separate contact will be provided. So you should have this contact numbers in your pocket, okay, or pasted on the notice board or somewhere that people can reach out, right? So if you have a cooling water pressure related problem, will you call the electrical guy? No, right? You will call the technical guy, the water guy, correct? So if somebody is asking you, what should I do in the dry dock as soon as I enter? Nothing. Just wait for the opening meeting. Okay. In that opening meeting, try to collect as many detail as you can, the contact numbers and everything, the contact points. So when you face problems, contact this guy. Simple. Okay. And after that, it in the opening meeting, it will also be discussed about the action plan of what is going to happen, which team is going to work where. So there will be a number of teams boarding the vessel and doing different jobs at the same time. What you have to be mindful that, okay, if somebody is trying to work on the propeller, you don't start working on the main engine, correct? Do you understand?
Yes. Yes, sir.
And why is that?
it has to be turned and all those things.
Correct. So somebody is working on the propeller, and what you are trying to do, you are trying to work on the main engine, which is totally wrong. So that is why a schedule is provided, right? So these are the timings at which the propeller will be worked upon. During this timing, the main engine job is not allowed. So there is a schedule list. You should try to follow that schedule list. You should be mindful of that. So if somebody is coming and asking you, I am going to weld, you don't say that, okay, you can go and weld because it is a dry dock and you are allowed to do whatever you want. No. You go and check your schedule list and you see, is there any other job which is taking place in the same place? And if this is obstructing with that welding, then you should not allow him to weld, right? Normally to take these decisions, there will be somebody, but from the vessel side, as a watchkeeper, you are the representative from the vessel on your watch. Then you should stick to the schedule list and the standing orders provided by chief engineer. Okay. Okay. So
सर एक क्वेश्चन था सर, ये ड्राई डॉक से रिलेटेड सर.
बताइए.
सर ये पूछा है डायनेमिक बैलेंसिंग ऑफ व्हाट पार्ट डन इन ड्राई डॉक.
Many parts, not one part. देखो, नॉर्मली डॉकिंग सर्वे जो होता है ना, उसमें आपका जितना मूविंग पार्ट्स है उसी का डायनेमिक बैलेंसिंग होगा. करेक्ट. मूविंग पार्ट्स क्या क्या है बता.
Propeller dynamic balancing will be done if a turbocharger is removed, then turbocharger, this shaft dynamic balancing also will be done, no sir?
Exactly. So basically turbocharger जो है, it is not required that it will be only overhauled in the
Dry dock, yeah.
dry dock.
Yes,
But normally what the vessel prefers is that to reduce the off service hours at sea, it wants to get it done in the dry dock only. So in the dry dock, you will be removing the turbocharger, taking out the rotor and sending it to the workshop. In the workshop, the dynamic balancing will be done. Okay. So that is there. On the propeller, probably yes. If the propeller is removed, if the propeller is scrapped, if the propeller is repaired, right, then the dynamic balancing could be done. Right? Both thruster. If you're changing the shaft or if you are cropping out the blades, then also. What else? Hold on, I will share my screen. Okay, can you see?
Yes, sir.
Okay, before going there, let me explain. So, which is the most crucial timing during the vessel stocking? That is one question in your MMD.
Sir, sorry, sir. Can you come again with the question? It was not clear.
During the docking process,
Yes, sir.
what is the most crucial timing?
It's like when the vessel sits on the keel block, the time when it is sitting.
Okay, and why is that crucial?
Sir, because while the vessel is the aft part of the ship, that is the one contact point which will be sitting on the block. So there will be this upthrust acting will be very high. So we have to maintain a positive GM. Positive means, yeah. So if it is not there, there is a possibility of the vessel like toppling or not sitting, like sliding from the blocks.
Mhm. Okay. What
Uh,
else?
so while the vessel is sitting on this block, before only we should ensure that we have the GM is positive and we have sufficient GMs. So when the vessel is sitting, it should not be there should not be any loss of GM, and because of that we'll have problem like this.
And also,
Mhm.
sir, this vessel sits on the block, that it starts sitting to the aft. So we have to make sure the aft, like when it is sitting, there is no deformation, and the sequence is carried out properly. Like it is sitting from the aft until forward in a very sequential way.
Correct. Well, both the answers, they are actually correct. Okay. But it needs a little bit of refining. Okay. So what happens as soon as the vessel is going to the dry dock, right? When the deballast process starts. So when it is inside the log gate and when we start deballasting, uh, I actually forgot to mention this. That is why I am interrupting between the propeller. So inside the dock, you will be like this. Okay, that is your vessel, and your water level will be quite steady, right? Like this. That is the water level, and that will be your blocks. Okay, the vessel is not yet sitting on the blocks, right? So when you start deballasting this water, the water level will be going down, correct?
Yes, sir.
So
Yes, sir.
so what will happen? There will come a period जहाँ पे your vessel will be something like this. My drawing is a bit exaggerated, so don't mind. So those are the blocks, right? So when you start deballasting, there will come a point where your vessel is just about to sit. And which part will be sitting first? Your aft part, that is the stern part, the stern frame actually, right? That will be sitting on the first block. When it is just sitting on the first block, that period itself is very crucial. Why it is crucial? Because what happens, we have all studied in the naval army. So there is a center of gravity, you know, which is acting like this. If you look at, so there is a center of gravity downward, right? What is acting upward?
Sir, your sound
Sir,
is not
voice.
clear.
अभी ठीक होगा शायद. So center of gravity is acting downwards. What is acting upwards?
The buoyancy.
Buoyancy is acting upwards. ठीक है. So what is that metacentric height here?
Zero. There is not GM.
So what happens? Your kg is equal to km.
KMS. K is equal to KM. Yeah.
So your center of gravity is in line with the buoyant force. So what happens here when you touch the block, right? So what happens to the buoyant force?
It lacked on the up part.
No, now there is no water.
No buoyant force.
Yes, sir. No buoyant force. Yeah. Sorry. Yeah.
There is no water. That is why it is starting to touch the block. But then what is the effect that it creates?
Only down, only weight is acting. There is no buoyancy there.
But the buoyancy is lost. Okay, I agree. But what else? What happens? What increases there? What has increased? When the water is not there, water is drained out. Okay. Water has already drained out. So there is no buoyancy, but something is there, right?
Weight of the ship.
Weight of the ship, correct. Which is acting on the keel block. And do you have a reaction from the keel block?
So it will also give equal force back on the keel, that very point. That means like the whole weight of the ship will act on that very point where it
That
is touching.
reaction will increase, sir. Increase. There will be an increase in reaction.
Yes. So what is happening when the reaction will increase, right? So that is equivalent to the buoyancy, right? So let's
Yes,
say
sir.
what was buoyancy trying to do? It was trying to push the vessel up. Okay, now there is no water, there is no buoyancy, but there is a reaction from the block. What that reaction is trying to do? It is trying to push the block up. So still the forces are equal and opposite. The G is acting down, the reaction is acting up. This much is understood?
Yes, understood.
Yes, sir.
Okay. So when these two are acting up, here you still have water, correct? In this particular area, you still have water. That is why the vessel is floating upwards and it is not touching the block, right? Is that clear?
Yes, sir.
Here
Clear,
there
sir.
is still water. Here there is still water. And mind you that the whole weight of the ship is acting on one single point on the stern frame. Okay. Now, if you look at the naval arc, I am not going to go in the derivation part. Okay, that you have already cleared. But what happens? There is a formula you might remember. Okay. There is a formula for GM. Okay. There is a formula for GM. It is called G is equal to P into kg divided by W minus P.
Yes, sir.
So this formula is for the virtual loss in GM. Okay. In a very layman words, if you ask me. Okay. So here is the K point. Here is the G point. Okay. When a upthrust is acting like this, and there is only one point where the upthrust is acting, that is this one. Okay. Even if your vessel has a list of 1 degree or 2 degrees, what will it try to do? This G will be acting away from the upthrust line, right? So there is a virtual loss of GM. There is a virtual loss of GM, and this is the formula for virtual loss of GM. So when there is a loss of GM, what happens? The vessel tries to topple, right? And this is at one single point. It is very easy to topple, right? So the period from which the keel block is being touched here to the period where this comes and sit. So this period is called the critical period. Okay. So this is called the critical period, during which the vessel is still taking the block. And what is the importance of this critical period? There is a virtual loss in GM, right? Due to which the vessel can topple. How this virtual loss of GM has come? Okay, there is a derivation for it. If you want, I can explain, but it won't be asked in your oral for sure. If you want, I can explain. But hota kya hai ki there is a GM which is being lost because there is only upthrust. There is no buoyancy. Due to this excess reaction from this one single point, your GM is reduced. Okay. When the GM is reducing, what is the action? It will create a couple like forces and it will try to topple the vessel. Okay. Is that good?
Yes, sir. Yes, sir.
So this critical period वाला एक question है आपके oral में. What is that critical period? So that you should know. Okay. And if somebody is asking you, what is P? क्या है ये P?
Upthrust.
P is the reaction from the
Yes, sir.
block.
Yes, sir.
Okay. What is kg? This is
KV
K
yes, sir.
and this is the center of gravity. So that is kg. All right. What is W? Is the weight of the ship. The
Mhm.
whole weight of the ship is here. Right. P is again the upthrust. Right. So let's say if the center of gravity was here. So P hello. 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 बोलो.
Sir, can you hear us, sir? Sir, hi, sir.
शायद फोन पे बात कर।
Hi, can you hear me? Oh, sorry, I got a call. Okay, so where were we? We were somewhere here. Yeah, the critical period. So that is the critical period from where the actually you have the first point of contact until where the vessel takes the block. And this is the formula for the virtual loss in GM that happens during the critical period. And if your metacentric height is basically reduced, then you will face a problem that there is every chance that your vessel can topple. That is why when you actually try to arrive the dry dock, right, a tank condition is provided. What is a tank condition? So the docking master, he will send a tank condition plan to the vessel that before entering the dry dock, you should be coming by the stern. You should not be coming by the trim forward. That is number one. To maintain this trim by the aft, what are the tanks that you should have empty and what are the tanks that you should have filled? And what are the tanks that you should not have anything? I mean, slack tanks you cannot have. Because what happens due to a slack tank?
Free surface effect.
Free surface
Free
effect.
surface. Correct. So when you have free surface effect, there is further loss of GM, right?
Yes, sir. Yeah.
So that is why you should not have a partially filled tank. You should have the tank either completely filled or completely empty. And that tank condition will be provided by the docking master. And that is for this particular reason that your critical period goes smooth. Okay. Why you should not come trim by forward? What is the reason?
In forward, it cannot take the whole weight of the ship. On the aft part is designed such a way it can take the whole weight.
I think the aft, the thickness of the plates in the aft will be more, sir. The scantling will be less. The scoffin plate will be more thicker.
Exactly. So the strongest part of the ship is basically the stern frame. Okay. If you remember your naval arc, so that was your stern frame, this one. And this is like a bulb plate. And from here starts your coffin plate, which is like this, right? So this part of the vessel is the strongest. Okay. That can bear a maximum point load. The point loading it can take. Whereas the other parts of the vessel, it cannot take that point loading because of this scantling and also because of their shape. This is a bulb shape. Okay. What is a bulb shape? It is like this. The cross section is like this. Correct. What is a channel shape? Like this. Like this. This is called the I-beam. This is called the channel. This is called the bulb. So naval arc में आपने बहुत सारा पढ़ा होगा. But the whole and soul of the story is that the reaction forces, the point loading forces is maximum it can be taken by the stern frame. That is the reason. Oh, did I stop the share? Sorry. Now we can go to the propeller. Okay. So for the propeller, when you go to the dry dock, okay. So if you ask me soon after the meeting what you should go and do first, so you should go around into the dock and go around the vessel and check for the condition of the hull immediately. That is what is more important. Why? What is the reason? Why you cannot check it later? What is the importance of that inspection? The visual inspection?
We have to ensure that no further deformation has taken place during the docking process.
See what happens in a dry dock, the job is going very fast. Okay. So they might have a plan to start the blasting as soon as possible. So before blasting, what they will do is they will do a high pressure washing. So when they start doing the high pressure washing, basically your barnacles are flying out. Okay. So before they start the high pressure washing, you should go and have the pictures and other things of assess the condition of the hull, how much fouling there has been. That information is really required to assess where your previous paint maker, paint supplier, or the previous guy who has prepared your hull surface, it has been satisfactory or not. If he had provided a biofiling paint with a very high cost, right? Has that worked or has that not worked? ठीक है, वो जब painting blasting कर ही देगा, how will you assess the condition? You can't. So before doing all these things, the hull condition needs to be ensured. ठीक है, how much fouling is there? So you can have a cost benefit analysis. That is the information for the company to decide. ठीक है. So for example, there is a new biofouling paint in the market. It is called X7. Okay, and it is a hell a lot expensive than the other types of paints. Okay, so normal biofiling paint, if you can buy, let's say, for 500,000, this one is costing 1.5 million. But then it is giving a guarantee that okay, that your paint will last for 5 years without cleaning, because the biofouling properties are such, and it can give you a fuel saving of 2%. Right? So that is what the paint maker is promising you. But let's say if that does not comply, then you should get your money back, right? So that is why assessment of the hull is really important to understand the previous paint that was applied. ठीक है, वो एक चीज. Another important thing is the rudder. So when you have the rudder, let's say it was already punctured and leaking. Now you are in the dock with all the water pumped out, and the rudder is filled with water because it is punctured. What will you observe?
Water, if it is punctured means water will be like we can see the water coming out from the rudder if we remove this rudder drain plug. So if water is there inside the rudder, that means the rudder has been punctured or some damage has been happened to the rudder.
What I'm saying is, see, this is your, I will draw it here only, and not go to another page. So let's say this is your rudder, okay? And this is the rudder stock. Now you are just entered the dry dock and the deballast has just finished. If there was a crack here in the rudder, okay, and there is no water in the dock, if there was a crack here, you will observe the water coming out of here, right?
Yes, sir. Yeah.
Correct. For that, you don't have to open the drain plug also. Drain plug is here.
Yes, sir. Yes, sir.
Okay. So as soon as you enter the dry dock, and if you go and stand here, if the rudder is cracked, if you stand in the dock, then you can actually see this water which is dripping out. And there could be many cracks. I'm not saying there is one. There could be many cracks, right? So water could be seeping out of all these cracks. If you go after 2 days in the dock, this water level might have reduced, right? So you will feel, the water is not seeping out from here. That means this part is okay. Correct? Do you understand, Mahendra? Ganesh?
No, sir.
Yes, sir, I have understood.
How about you, Mahendra?
I have understood, sir.
Okay. Is everybody okay?
Yes sir, okay sir. सर ये
Nobody
रडर का
sleeping?
इंटेग ये सर रडर का इंटीग्रिटी टेस्ट कैसे करते हैं सर?
इंटीग्रिटी टेस्ट होता है, हम रडर पे भी आएंगे प्रोपेलर के बाद, उस पे बताऊंगा.
ओके ओके
तो उसमें basically there is a hydrostatic test, and that hydro you have to fill the rudder and you have to raise the water level inside the rudder to a head of either 2.4 meters or your summer draft load line, right? And then you have to observe it for 30 minutes that there is no leakage. And if there is no leakage, your rudder integrity is fine. Okay. But
यस सर.
इसको मैं बताऊंगा. All right. So this is the visual inspection that you can go and do. That your rudder is cracked and the water is seeping out. After you go after 3-4 days of the dry dock, this water level might have reduced, and water may be seeping out only of here or ho bhi nahi raha ho, right? But this part you have already missed, the one which is on the top. Okay. So that is why that visual inspection is required. Okay. So going back to the propeller. So as we saw in the previous class, okay, in the dry dock, does the propeller have to be removed? Is the question. Mahendra?
Sir, it depends upon the PMS and also the condition.
Okay. But is it dependent only on that? That if, let's say, the dock comes and tells you that we are planning to remove the propeller.
What kind of method you have chose for the propeller with the class?
Correct. So those who were there in the previous class, they will know that we had already discussed this, that there are a number of inspection methods that the vessel has already opted for. So if your company has opted, there are 3 or 4 methods that the company is allowed to opt for. So according to the class rules, if you choose method 1, while the vessel is delivered, if you choose method 1, then you have to draw out the propeller and the stern tube, everything. If you go for method 2, right, then you don't have to draw out the shaft. Only the partial withdrawal of the propeller will do to inspect the crack on the boss, the taper shaft, and so on. If you are following method 3, okay, then you don't have to draw out any propeller or shaft. कुछ करने का जरूरत नहीं है. There is a system which is called screw shaft monitoring system. If you have the reports of the screw shaft monitoring system satisfactory, then you don't need to touch the stern tube, shaft, and so on. You don't have to withdraw anything. provided your propeller drop is measured correctly, right? Lube oil reports are satisfactory, vibration reports are satisfactory, stern tube temperatures are satisfactory, and the record of how much you have topped up the stern tube, right, is satisfactory. So this is all consolidated in a report which is called the screw shaft monitoring system. So if you have a screw shaft monitoring system and the class has verified that, then definitely you are following method 3, and for that there is no um, need of withdrawing the propeller or the shaft. Is that understood?
Yes,
Yes,
sir.
sir.
So उसका भी material जो है आपके 4B and 6 group में I have already sent it in the previous class. Just have a look. Okay. So different methods are there. So whichever method you have opted for, so that will be taken into account. Okay. If you go for method 1, then definitely you don't have to have a screw shaft monitoring system. You can simply withdraw the propeller, and but that is taking time and effort and money also. That is why most of the ship makers, they go for a screw shaft monitoring system. Okay. So now you know whether propeller has to be taken out or not. Okay. Now what you should do, uh, you should look at the propeller damages. Okay. What are the damages on the propeller? So what could be the damage on the propeller? Any idea?
Crack, sir. Bend of blade, sir.
Cavitation on the propeller blades.
Correct. Cavitation, cracks, bending. What else?
Erosion.
Erosion, yes.
Thinning down
What
of
else?
the propeller blades. Thinning down.
Thinning down is there, yes.
So,
Anything else you can think of?
corrosion, sir. Corrosion.
I would say okay. Corrosion, not much. See, as soon as you go into the dock, okay, and stand near the propeller,
Yes, sir.
can you see the thinning down? Can you see the cracks? Can you see the bend of the blade and so on? What is the first thing that you will see?
Chipping off of the blades.
Chipping off, you can see, yeah. But you will see the fouling on the propeller, right? The first thing. Without remove the fouling, you cannot see a crack, correct?
Yes, sir.
And you should count the number of blades. I had one vessel. I was standing in the dry dock. I was surprised to see there is no one blade. It's missing. So while it was coming into the dock, so there was a big noise, and the blade was completely broken. So that also happens sometimes. So that propeller was already about to be discarded, and we already knew that that fatigue is there. So we were already advised, even before entering the dry dock, 2 years before entering the dry dock, that you should not be operating the main engine more than this particular load, because the propeller cannot take it. So even we were following that, so there was some fatigue, and while coming into the dry dock, it hit somewhere, I don't know, and then we lost a blade completely. So if you have 4 blades, make sure there are 4 blades. Okay, if there are 5, then 5. Then you see the fouling. Then after clearing the fouling and everything, the fouling will tell you one thing. There are few uh, propellers. Normally the propeller is not painted, okay? But in the recent trends, in the last 10-15 years, uh, people are also painting the propeller. with the X7 paint. Okay, just to not have the fouling. Sometimes it is effective, sometimes not, right? So wherever the paint has been applied, so assessment of fouling is really important. Then you should go and have a look at the chipping of the blades, as you said, then bending of the blade, right? And then look for the cracks, okay, broken blades, corrosion, you already mentioned, hairline cracks, okay, that will be assessed only after cleaning. Erosion, cavitation, whatever you can name it, that you should go and check, okay. So tell the surveyor at least 5-6 points that you will check, okay. So what are the 5-6 points? Number 1, propeller drop. Number 2, blade deformation. Number 3, corrosion. Corrosion and erosion, okay. Number 4, cavitation marks, okay. Number 5, did I mention crack?
Yes, sir. Yeah.
And that partial blade loss, that is chipping of the blade, that you should see, okay. So tell him at least 5 point, right? After 5 point, the question is going to come that, okay, let's say, what are the different technologies by you can repair these particular defects that you mentioned, okay. Now let's start with crack, okay. If you have a crack, then what are you going to do? You should tell him the position of the crack, where the cracks can be found, okay. Then what can you do with the cracks? Now moving away from the propeller, in the engine room you have a component, whether the component is cracked, what are you going to do? What are the different methods of addressing crack?
Dye penetration test
Okay.
and NDT test we can do, like this ultrasonic testing.
Sir, approved surface crack detection method.
Surface crack?
Sir, this one, um, destructive test, sir, and the non-destructive test.
You can do the NDT, okay. With the NDT you found, okay, there is crack. How to deal with it? Forget the propeller. I'm giving you a steel plate which has crack. What are you going to do with it?
सर सर्फ उसे डिपेंड अपॉन द थिकनेस सरफेस प्रिपरेशन दोनों साइड से करके वी ग्रूव बना के उसमें बिल्डिंग करेंगे और
Okay.
एक और चीज है कि जैसे मान लीजिए थोड़ा मोटा प्लेट है वो थोड़ा मान लीजिए कुछ लाइक 5-6 सेंटीमीटर क्रैक है तो उसके दोनों लास्ट एंड पे ड्रिलिंग करके और फिट कर देते हैं दोनों साइड और फिर बीच बीच में वो एग्जैक्टली मुझे उसका नाम नहीं याद आ रहा बट उसको मतलब इट इज लाइक अ सीइंग यू नो बाय फिटिंग द बोल्ट
Okay, I will take that point. What else? What else you can do?
उसको गॉजिंग करके फिर उसको बैलेंस करना पड़ेगा.
Correct. That is also possible. Yes. What else you can do?
उसको अरेस्ट करके मेटल लॉकिंग कर सकते हैं.
Perfect. What else? देखो आप जितना क्वेश्चन आंसर बताते जाओगे ना तो सर्वेयर भी ऐसा what else पूछता जाएगा. So
या फिर डबलर प्लेट एक लास्ट ऑप्शन वहां पे.
या अब डबल प्लेट है तो इंसर्ट पे भी क्वेश्चन आएगा फिर. तो सी द सर्वेयर ही इज अ हंग्री भेड़िया. ठीक है. The more you present him with the answers, the more he is going to ask you what else. So the how to address this particular question is, if he is asking you how can you address the crack, okay, you should tell him limit your answer to a number. Just tell him that there are at least 5 different methods by which the crack can be addressed. Number 1, number 2, number 3, number 4, number 5. That's it. After that, keep quiet. He will not ask you what else. Right? So limit your answers. So that is what I will say. And every answer that you give, try to give him as a bullet point, because he is not going to take your okay, maybe, I think, probably. No, he is not going to take that answer. Every answer you try to give him in the form of bullet points, like you are doing Microsoft Excel and Word. उसमें बुलेट मारते हो ना, तो वैसे ही 4-5 बुलेट पॉइंट उसको दे दो and limit your answers. If he's asking what are the causes, there are 5 different causes which is possible. Other than that, you start thinking. But he knows that you are confident about at least 5. Then he is not going to ask you any further. Okay. So when you have cracks, not in the propeller but in the plate only. So what you should do? Okay. First is, you should assess where the crack is and how much the crack is. If it is a surface crack, okay, then what you are going to do? Just grind it off and your crack is finished. If the crack is deep, then you are going to grind it off. I'm just going to draw. Hold on. So this is a plate. Okay. The crack is here. This is the only point of crack. What are you going to do? You are just going to grind it off. So the surface will look like this. Okay. यहाँ पे grind कर दिया. This is the place of grind. If that is not going to affect your performance for what the propeller or the steel plate is intended for, if that is not going to create a difference, no worries. Just grind it off. Your crack is finished. Okay. Then number 2, if the crack is deep, let's say this is the crack. This is the type of crack. So this is not a surface crack. Okay. So what are you going to do with this? Just grind it off, prepare the surface nicely. Okay. Like this. And then fill it by welding. You can fill it up by welding. After welding, what you have to do? Welding will not be very smooth, right? It will be something like this. So you have to grind it off. Weld and grind. So you have to prepare the surface, right? Fill the crack by welding, and then you have to grind it off. Make the surface smooth. When I say smooth, how do you define smooth? Do you know hull surface analyzer?
Yes, sir.
Hull roughness analyzer.
Yes, sir. Yeah.
Right? So basically, there are analyzers, okay, where you can actually measure the roughness. So if the roughness is less, then the smoothness is more, correct? And it should be more and more smooth, because if you have rough parts like this, it will be giving stress points. It will be giving rises to the stress points. So that is why welding, grinding, and polishing, right? So that should be considered. If you have the crack, which is making into 2 different parts, right? Then also the welding, grinding, and polishing is recommended. Then not only this, when you do the welding, grinding, and all these things, what happens? There is internal stress is introduced to the welding. So what you should do? You should consider stress relieving. Now stress relieving.
Sir,
What does
voice
it
is
do?
not clear, sir.
Huh. So whenever you are doing welding, no, it is giving stress points. Okay. So due to welding. Now to remove the stress points, you should consider a process called stress relieving, right? Stress relieving process. Have you heard of this? Stress relieving?
Yes, normally if there is a like an opening in a continuous plate, stress can be relieved by like thickening around the plate, like adding doubler and all.
No, stress
Sir,
relieving in the sense, हाँ
it is
बोलिए,
heat treatment, I think.
heat
Stress
treatment, exactly. So it is a process called normalizing, you know,
Annealing,
annealing.
normalizing.
So do you know the difference between all of these things? नहीं तो एक sheet भेजता हूँ उसमें देख लो. ठीक है. These are the stress relieving techniques. Normalizing है, you should not quench it, you know, and things like that. So I will send you this. There are only a few points in that particular sheet. I will send you stress relieving. Okay. Provide a heat treatment by which your welding, the stresses due to welding, they can be relieved. Otherwise, uneven stress rahega and you will have cracks again. ठीक है. Okay. हाँ. So metal locking part that can be followed, but not in the propeller. Okay, not in the propeller. Metal locking cannot be followed in the propeller. Okay. Cropping you can do. Okay, but to go into detail, not all the areas in the propeller you can do the grinding, welding, cropping, and so on. Okay, so the propeller area is being divided into 2-3 different parts. Okay, in some parts you can do the welding, and some parts you cannot do the welding at all. If you have to do the welding, you have to involve the class and the propeller maker. Is that understood?
Yes, sir.
Yes, sir.
So let's say if there is a blade of propeller, that blade of propeller itself, one blade of propeller itself is classified into 2-3 different areas depending upon the size. Okay. So 2-3, it is separate. I mean, it is bifurcated into 2-3 different parts. And the bifurcation is based on the radius. So 20% of the radius you cannot do welding. Then 20 to 30% of the radius you cannot do this. You cannot do grinding, and more than that you can do anything, right? So like that, areas are defined for each and every blade. Okay, in that area, if the propeller maker says that you can't do welding, means you can't do welding. You have to follow some other method. Okay, so how that looks like, I will show you. It is also mentioned in the class rules. Hold on. Okay, you see that zone? So this is 20% of the radius, yahan tak. Okay. From here to here is 40% of the radius, this particular zone. From here it is 60% of the radius, and here is 80% of the radius, and here is 100% of the radius. Okay. Do you understand this drawing?
Yes, sir.
Okay. So what can you do in 0.2 of the radius? What can you do in the 0.4 of the radius? 0.6 and 0.8. I will show you. So here he says the propeller blade is divided into three categories, A, B, and C, right? So what is A, what is B, and what is C? So this is the A region, okay? This is the B region, and this is the C region, okay? So that is how he has decided, and this is by the propeller maker. If your defect is in the A region, okay, hot fairing, that is the only acceptable technique which should be followed, okay? The remaining of the techniques like building up by welding, erosion removing by welding, filling the blowholes, these are all unacceptable in region A. Which is region A? That is this. Is that understood? Now, in region B, most of the repairs are acceptable. In region C, everything is acceptable. So this particular table is given in your propeller manual itself. Okay? Ki in which region what repair can be done. Is that understood? Is that clear?
Yes, sir.
Okay. I will
Yes, sir.
send you
Clear.
one. So I have one propeller manual which exactly mentions the same thing, but then it is mentioning a lot of calculation. That is why I did not take that out. This one is easier to just get the fundamental right. So if the surveyor is asking you how will you address the defects on the propeller, so you tell him what could be the defects on the propeller: cracks, erosion, deformation, and so on, right? And how will you address the crack? You will address the crack in at least 2-3 different ways. You can have the surface crack just grinded off and polish. Okay. Then second thing is, if the surface crack is deeply penetrating, then what you should consider doing the surface preparation and doing the filling up the crack by welding and then polishing it. Okay. And then the third repair, what you can do? What can you do? What is the third repair you can do? Let's say the crack is here. यहाँ पे crack है. So it is a process called cropping. You can crop the propeller like this. Means giving it one more shape. What is cropping? That you are reshaping the propeller. Only on the edges. Huh? If you have crack like that, then you can go for cropping. Okay? Which does not affect the propeller performance much, but the cracks can be removed. So that cropping can be done. Okay. But then the question arises, where can you follow all these techniques? In which part of the propeller can you follow all these techniques? For that, you have to follow this particular table. Okay. So the propeller is divided into zone A, zone B, and zone C according to the radius. Okay. So you can, when he's asking you, then you can draw this drawing and explain 0.2, 0.4, 0.6, 0.8, and 1. Okay. And then you can tell him that is split into zone A, B, and C. In zone A, what you can do, in zone B, what you can do, and zone C, what you can do. Is that clear enough? Guys?
Yes, sir. Clear, sir.
ठीक है. So if there is a propeller deformation यहाँ पे edges पे, if there is a propeller deformation on the edges, when I say deformation, then what I mean is कि a propeller which is like this, okay, has now become like this. Okay, what can be done? Will the welding help? How are you going to address this one? The propeller tip is deformed. Anyone?
We have to cut that part and put new parts.
Okay. What other option? Ganesh? Any inputs?
We'll gauge out that part, and then we'll balance in the other wheels also, other blades also.
Okay. So what happens is that if you have something like this, there is a process around it, which is called the forming process. Okay. So what they do in the forming process is they will get a jack. Okay. It is a form of cold repair only. So there will be a jack. They will place the jack like this. Okay. This jack, you can say it is like this. Okay. So this jack will be clamping both sides of this particular tip. Okay. A little bit of heat will be applied to this area, right? And the jack will be turned in this particular direction. So this particular tip which is bent will be straightened. This is called the forming process. Is there a doubt?
No, sir.
No, sir. No, sir.
Okay. So that is one more way that you can repair this particular bend. Okay. So it is called the forming. If you look at, एक minute, in this document, I don't know if it is mentioned that forming. Hold on. Not quite sure. Hold on. Wait. Okay, here it is mentioned as fairing. Okay, that fairing is also by application of heat and providing that by the jack, that force by the jack. So the fairing here he has mentioned as fairing, but it is also called forming. It is called hot forming and cold forming, right? So यहाँ पे cold fairing लिखा है. Both are correct. Both the terminology is correct. Here, see, cold flaring, he is mentioned acceptable only for fairing or trailing edge of the blade. Okay. So basically he mentions this one, right? So if it is a problem on this particular part, then you can do the fairing as he is saying. And even if you say forming, the forming is not wrong. Okay. So there is hot and cold, both procedures are there. Here is saying cold fairing, so that can also be done. Hot fairing can also be done. But whenever you do this fairing process, forming process, यहाँ पे एक stress relief चाहिए. Okay. Stress relieving by providing heat treatment, that is yet to be considered. Now I will provide you a document where it will clearly mention which part of the propeller, what is the repair process, and whether the heat treatment there is required or not required. Okay, ठीक है. So that is what I will provide you. What is the area of the propeller to be repaired, and which technique exactly to be followed, and whether if the heat treatment is required over there. Okay, I will present you that. That I will do. Okay. Here he is mentioning the propeller drop. I don't think you have any doubts with the propeller drop. If you have any doubts, please reach out. Clearance. This one we had already discussed in the last class, right? Where to take the propeller drop? If you remember.
Yes, sir. Between first and second or third ceiling, aft ceiling.
And what is the position while you take the drop?
Top and bottom. Like first piston has to be on the TDC.
Yes, you can see my screen, right? That is what is mentioned. And these are the results of measurement, right? So he's putting the poker gauge onto the, you see, this is where he's putting the poker gauge, and the poker gauge is going to touch the chrome liner, and the result will be taken on the chrome liner. Okay, so that is this, all these things we have discussed in the previous class, right? Inspection of stern tube seal. Stern tube we have discussed in the previous class. But if you have doubts, please reach out so we can clear this. Bow thruster and side thruster we have not come to, but I will take out another document. Hold on. So for those who have not seen where the gauge is fitted, so this is the gauge. What gauge is this? This is the poker gauge, and the poker gauge is fitted and screwed onto this particular thing, and then this is the moving depth gauge. that it goes and sits on the chrome liner, and then you can take the measurement like with the vernier caliper over here. ठीक है, यहाँ पे measurement ले लो, that will be your drop. All right. What else I wanted to present is this is also from the propeller manual. Fitting method of the propeller. That is the name of the document which is provided by the maker. Okay. And this is the same thing as we discussed, what he is trying to mention, right? So this is okay. This is pushing up the propeller. Okay. So we already saw that for pushing up the propeller, what are the criterias? Okay. That temperature versus the travel, then the travel versus the hydraulic pressure that you should apply. ठीक है, तो वो पूरा यहाँ पे टेबल बना के यहाँ पे दिया हुआ है. Okay, right? Now here see, he has mentioned for pulling out the propeller. So this is the case to be applied when pulling out the propeller. So pull out के लिए क्या करते हैं? What are we going to do?
We will first take out the nut, and then we will put the nut in a loose, little loose, and then we'll put something after the nut so that it can take the impact from the propeller boss, and then we will hydraulically expand the propeller boss, and it will become loose, and then we'll take it out.
The method you have stated is absolutely right, but let me tell you that when you answer in MMD, what you should include in your answer is also this, that the propeller is here, right? This is the propeller blade. Okay, that which is not shown here. This is the propeller blade, correct? As soon as you apply the pressure, this blade with the boss, the whole propeller is weighing about 2 tons, 5 tons, I don't know, depending upon the size of the ship. Then it is going to slide down, correct?
Yes.
And who is going to stop that?
For that only, we will put the nut back, and after the nut, we will put some on like 11. We'll put something which will take the impact.
No, sir, I
Correct.
think it has to be hung from the top.
Exactly. So that is what I'm coming to. So what you should exactly do is, even before following all this procedure, ये आपका stern frame है, correct? Your ship is like this. So what you should do, you should weld eyes on port and starboard side, and then if this is the propeller blade, you should weld another eye here, and then support it with the chain blocks. Okay. So now this rushing down should not be there. It should simply, with the help of chain blocks, you should be able to put it there on the wooden block. That is acceptable. Something which is running down is dangerous, right? So with the help of chain blocks, you are going to support the propeller basically. So for that, you have to weld the eyes to shift the load also. Okay. And then after that, you follow the procedure that you want to follow, right? So that support is very important. So weld the eyes, support the propeller, and then go for this particular method. So this is for withdrawing the propeller. Everybody is, familiar with the withdrawal procedure of the propeller.
Yes,
It
sir.
is a very simple process. Like, do you want me to explain this?
Yes, sir. Can you please explain it in short?
Yeah, no worries. So this is your propeller. As I said, there are grooves, right, on the propeller boss. Internals of the propeller boss में groove रहता है. तो उसमें what you are going to do? You are simply going to provide this particular pressure. As soon as the pressure is between your shaft, taper shaft, and the propeller boss, your propeller boss is going to expand because of the hydraulic pressure. As soon as it expands, the coefficient of friction becomes nil, right? So the propeller can actually start sliding backwards, right? But it will not slide by on its own. How will it slide? There is a mechanism. I will show you. I hope it is mentioned here. If not, I will take out some other drawing. This is for pushing up. This is the arrangement for pulling. So what is not mentioned here is basically like you remember that purifier ka आप bearing निकालते थे. How did you remove the bearing? Purifier bearing? That purifier shaft bearing, how did you remove? Anybody remembers?
तो सर सेंटरिंग करने के लिए बोल्ट रहता पहले वो
Once again, I could not hear you.
सेंटरिंग करने के लिए वो बोल्ट दिया रहता है वो पहले लूज करके तब उसको निकालते हैं।
ठीक है, बट वो बेरिंग को कैसे खींचते थे शाफ्ट से?
अरे पाइप लेकर के सर इनर रेस पे टैप।
So let's say, let me make the question clear. This is a shaft. ठीक है, इस पे ये बेरिंग है, इसको कैसे निकालोगे?
इसमें सर पुलर से निकाल सकते हैं।
पुलर ना, करेक्ट. So basically you just put a puller, okay? So puller can be of different shape and sizes, right?
यस
So what I mean to say, एक पुलर आप ऐसा भी लगा सकते हो, you know, which is clamping like this, correct? This can be one type of puller, correct?
Yes, sir.
यस
Another type of puller,
सर स्ट्रॉन्ग बैक टाइप भी होता है।
strong back type, correct? So ये ऐसा bearing है, right? What can you do? आप एक प्लेट यहाँ पे डाल सकते हो, और ये प्लेट में there is a hole, you know, from where you can pass the bolt, right? Here is also a hole, here is also a hole, and this is also a plate. So what you do, you place one puller over here like this, और यहाँ पे bolt डालो, correct? These two bolts are there. Then you put a nut here and start tightening these nuts. When you start tightening this nut and this nut, what will happen? This bearing will start to move in this direction, correct?
यस
So that is also a puller, right?
यस
Yes.
So this is the type of puller that we are going to apply here. Okay. We can find it on, I don't have that picture here in this manual, but definitely we can find it on Google. Wait, I will show you. I had already posted some pictures previously, I remember. But yeah, let's randomly refer to any one of. ये बहुत simple procedure है. It should be given anywhere here. Somewhere here, see. ये strong back डाला है, ये इसने puller डाला है, ये देखो. And that puller is actually screwed. The bolt of the puller is actually screwed into the ये hub of the propeller. Okay. And ये आपका nut है. और यहाँ पे what you are going to do, you are trying to provide a hydraulic pressure where this particular valve and line leads to that grooves inside the propeller boss. अंदर में जो small grooves रहता है for the hydraulic pressure, this leads there, right? Where this goes into your jack. Okay. Where this goes, this again goes to that same place. You can see 6 and 7. Here is also 6 and 7. वो grooves में जाता है, right? So what you do? You have to provide a pressure into this jack. How will you provide? Open this valve, right? And this line goes there. You provide a jack. So what happens? When you provide hydraulic pressure here, this whole arrangement, right? It tries to move back. When this tries to move back, you see, this is holding. This strong back with the bolt is holding the hub. The hub will also move back. Is that understood? कोई doubt है?
And that propeller nut, it has to be reversed, I think. ऐसा कुछ होता है उसमें क्या?
The propeller nut can be reversed or it can be just slackened. That is also possible. आप propeller nut को reverse कर भी सकते हो. In certain design of propeller, you don't even need to reverse it. उसको सिर्फ slack करके छोड़ सकते. The pilgrim nut you are talking about, right?
Yes.
Yeah. Not in all the designs of propeller you have to reverse it.
Okay.
Yeah. So you can see that this is the loading ring. What is the loading ring? वो jack में जो निकलता है, which is actually exerting a force onto the surface, that is called the loading ring. ठीक है, आपका जो मेन इंजन का जो जैक्स रहता है उसमें भी आप देखे होंगे लोडिंग रिंग, राइट? So this loading ring is trying to come out by the hydraulic pressure and that is trying to push the strong back into the aft direction. When the strong back is pushed in the aft direction, the strong back is connected to your ये studs, ठीक है, और ये stud is connected to your hub. So when the strong back is moving in aft direction, the studs and the hub will also move in aft direction, and then you will have the propeller easing out. Okay, is that understood?
Yes, sir.
So this procedure is very simple, and when you have to fit it, then it is the other way around. Oh shit! Hold on. I stopped sharing. यार इसको नीचे कैसे? See, here he has not reversed the nut. See, here he has only slackened the nut.
Yes, sir.
So it is not required that you reverse the nut. Okay. And here what he has done, यहाँ पे इसने wooden block रख दिया है. So when he is pulling with the strong back, right, uh, it is not going to come and hit the nut. It is going to hit the wooden block only. So that is still acceptable. In this particular procedure, the strong back is also not required. Okay. This will slide down by its own weight. This propeller is huge. Okay. But if it doesn't slide down by its own weight, then you have to use that strong back. Sometimes it happens, that it is a nice shrink fin arrangement and वो पीछे नहीं आ रहा है, then you have to use a puller kind of thing. So यहाँ पे you will place a strong back as we already discussed. यहाँ पे strong back, it will be something like this, and then you put that arrangement, and then you start to inject pressure. Yeah, so fitting and removal is a very easy process in which no extra technique is required. But while fitting, you have to remember this particular graph that you should include in your answer. Okay. Is that fine?
Yes, sir. Yes, sir.
Okay. Now I will send you 2 or 3 documents. One is this propeller manual where this graph is there. You can simply draw a gist of this graph in your examination. Fitting and removal procedure I am sending you. And the third thing is this graph and also propeller repair technique. In which area, in which zone, what is the repair that you can carry out, and whether the repair can be carried out and you need a heat treatment. Okay. So that is the table I'm going to send you, and very easily just follow that. Okay. So if somebody is telling you I have a crack in my propeller, how to repair it? You should ask him a question. Where is the crack? What is the location of the crack? What is the location of deformation? What is the location of erosion? Okay. How did you verify it? Did you verify it with a dye penetrant test or ultrasound or whatever? Okay. Is that fine?
Yes.
So there is no one answer to it. There is a table of answers. There is a possibility. There is a matrix to be followed. In that matrix only you can say, okay, this is how you will repair your fault. Okay. Similarly, there is a blind question from the surveyor. You need to cut out your engine. How will you cut out? Any answer for this?
Sir, cutout is for surgery is different type and man-made is different type, sir. To cut out.
Correct. But both have the same fundamentals. What is that fundamental?
To this one, we have to lift the lift the fuel pump cam guide
Correct.
by by locking nut, sir. That lock one lock is given. We have to put tool on the lock. Just take out the stop, that stop slot stopper, and that whenever in normal running condition fuel pump, that guide pin will be in downward side. So, and when we are that one we have to lock, means we have to turn on top side.
Okay. What you are saying is absolutely right, Ganesh. But
Yes, sir.
what the survey is asking, when you cut out your fuel pump, what are the things that you are going to follow?
One more, sir.
Okay.
That MEC engine is ME electronic engine. We have to cut out from the MOP panel.
Mhm. Okay. Not only that, in the
Reduce
previous
lubrication exhaust valve to be the lubrication of
yes,
that particular unit we have reduced now. Sir?
yes, you can see my screen.
Yes, sir. Can you, sir?
Okay. So in the previous classes, I had sent a document which is called the special running conditions. Okay.
Yes, sir. Okay.
So in the special running conditions, you will see, I'm just opening the document. If you can see it on my, so this is for turbocharger, how to cut out the turbocharger. For there also special running condition I had provided, and you see this one. So this is the answer which is expected. There is a table somewhere. Hold on. See. So this is the table of the special running condition. What you have pointed out, Ganesh, that is absolutely right. But you have pointed out this one, right? Fuel pump with roller guide that has to be lifted, correct?
Yes, sir.
But this is one part of the answer that has been provided. But what is the complete answer? Is that there are 4 or 5 cases in which the failure has been defined by the main engine maker. Okay. So this is the nature of action. If it is case A, or if it is case B or C and D and E, in all the cases, the action is different. Okay. See, if you have to cut out the unit, you have to stop the fuel. Correct. So that is why in all the cases, you can see the fuel pump roller guide has to be lifted because the fuel has to be cut out. There cannot be combustion. But what happens to the exhaust valve? In case A, it is working. In case B, it should be held open. In case C, it should be closed. And in all the other cases, it should be closed. What happens to starting air valve? What happens to the piston rod, crosshead, bearing, lubricators, and so on? Correct? So you should answer that there is a special running condition. Okay. And it is, if you have to cut out the unit, you have to ask yourself, why do I have to cut out the unit? What is the problem? The problem could be a leaking. The problem could be a broken piston ring. The problem could be anything. The problem could be on the exhaust valve. The problem could be on the lubricator, right? So you can see, if the combustion has to be stopped, that is case A, then these are the items which should be working, and these are the items which should be not working. Okay. If it is case B, that compression and combustion both have to be stopped. Here, see, there will be compression, but there will be no combustion. Here, there will be compression and combustion, which both have to be stopped. So like that, cases and cases wise, each component that should be working or not, that is what was expected in the answer. Did you see the difference in what you answered and what is actually expected? So वैसा ही, that is how you will be asked a question, okay, I have a crack in my propeller. Then you should not straight away go to that answer and say, okay, crack can be removed by welding, grinding, surface preparation, gouging, welding. No. You should ask him, where is the crack? If the crack is in a portion which is outside the 70% in zone C that we saw, ye wale zone mein, you see, in that particular zone, zone C, then you can do the welding and all. If it is in zone A, you can't even weld. For welding, you have to call the surveyor and he has to approve it, that why you should carry out this welding and why there is no other procedure. And a stress relieving has to be done, and the result of which has to be produced to the surveyor. He has to approve it. Okay. So that is where you should start your answer. So that is why I showed this.
Sir,
Is
can
that
you
okay?
showcase in the group, sir, this document?
I'm going to post all the documents.
Okay, sir. Thank you, sir.
Okay. So whatever we discussed here, that I'm going to post. Apart from this also, whatever the information I have regarding this one, that also I'm going to post. Is that fine?
Yes, sir. Thank you, sir.
Okay. Is there any other doubt that the class has?
Sir, I have
so far?
sir. This is out of the not related to this, sir, but I have a doubt related to the market.
Hmm.
I just had a word with the chief a few days back. He told me that container market will be very down from next year. Is it true, sir?
Yes, that is true.
Okay, sir.
That is absolutely true. Which company are you working for?
Synergy, sir.
Synergy. Okay. So again, see, I know that you have not been into, you know, we start thinking just like an engineer,
Yes,
but
sir.
he told you that the container market will be down, right?
Yes, sir.
That is compared to which year? Did you ask him
Uh,
that?
no, sir, he didn't tell me because this is a E series vessel. She came out of the dry dock 2 weeks back, and immediately after the dry dock, it is like it is laid off only till mid of January. They
Hmm.
don't have any like charter or anything. So that's what he was telling me.
No, no, there is definitely a layup,
Yes,
but
sir.
when I say there is a fall in the market,
Yes, sir.
okay, I should always see whenever you are comparing rise, fall, profit, loss,
Yes, sir.
okay. So ये सब से you should have a benchmark. What is the benchmark are you referring to?
Yes, sir. Yeah.
When I say that you saved some money, okay, what
Yes,
is the benchmark that you are referring to? So there is a fall in business. Definitely, yes, there is a fall in business.
yes, sir.
But what is the benchmark? The benchmark is 2019,
Okay, sir. Yeah.
where everything was still all right.
Yes, sir. Okay.
In the COVID, the business went booming, and that is the profit that you expect now. And you compare to the 2019 levels, it is a loss, right?
Yes, sir. Understood. Yeah.
So the company is still making profit. That means
Yes, sir.
because
Yeah.
in 2019 it was making a profit.
Yeah. Okay, sir.
So if they were running 10 ships to get that profit, now they will run only 2 ships,
Yes, sir. Yeah.
right?
Understood.
So
Yes, sir.
what will happen to the chartered vessels? Those 2 chartered vessels which your company got, they will lay it off, correct?
Yes, sir. Yeah.
And then they will find another route for this vessel where the bunker fuel and consumption will be less, and they will deploy it to that particular route, and that will get going. You will see that is how the market works.
Yes,
So
sir. Understood.
in my company where I am, it is
Yes.
always in loss.
Losses. Sorry, sir.
So
You
if
are
you
with
start,
which company, sir?
I am with Musk.
Musk. Okay, sir. Okay.
So, uh, so what is the definition of loss? According to me, you put $100 in the market. If you don't get $123 back, it is a loss.
Yes, sir.
If you get only $115, right? What is the extent of loss? 123 minus 15.
Yes, sir.
So $8 loss. But how
$8.
much did I put?
100. Yeah.
I put $100. How much did I
Yeah.
gain? I got $115. So $15 is actually my profit. But comparing to a benchmark of 123, I am $8 loss, right?
Losses. Yeah, sir.
So
Understood.
that is how they calculate here. I mean, it is a very weird scenario, but yes, I can definitely say the market and the trade is actually slowing down. Okay, the demand is reducing. That is correct.
Yes, sir.
But when I say it is going to fall, it is not going to be worse like 2008, 2012. उतना worse नहीं होने वाला है, right?
Yes, sir. Understood. Yeah.
Yeah. But stay strong. That is, I will say. That is what I will say.
Yes, sir.
The demand for engineers will never be less,
Okay.
whether the vessel is laid off or whether the vessel is sailing. Doesn't matter. You still need an engineer to keep your vessel alive.
Yes, sir.
And you look at the projection of the new buildings which have been placed into the dry docks, into the new building yards.
Yeah, sir.
So every company is ordering new vessel. Why? When the market is going to slow down, do you think they are crazy to order these vessels? No, right?
Yes. No. Yeah. Yeah.
So that is an indication, right?
Yeah,
And
yes, sir.
what the company is doing, they are getting rid of their old tonnage and they are converting that old tonnage to a new tonnage.
Yeah, yes, sir.
Yeah. So that is because if you have a bigger vessel to carry a bigger cargo and a smaller vessel to carry smaller cargo, the company has an option of to run which vessel to maintain their EXICII.
Yes, sir.
It
Yeah.
has that flexibility. So वो भी एक item है that you should consider.
Yes, sir. Understood.
So my company has ordered $4.5 billion. It has put into making methanol vessels, 20 ships.
20.
Each ship is 400. Yeah, each ship is about 400 meters long. Now you see 20 ships they are ordering for what? Such an expensive 4.5 billion, man.
Yes.
It's not small investment. So they have some projection. Just go with the flow, man. Nothing will happen.
Yeah. Okay, sir.
Okay, then I'll see you in the next class.
Yes, sir. Thank you.
Okay.
Thank you, sir.
Thank
सर
Any
ये कुछ
doubts,
डाउट
please?
थैंक यू सर।
हाँ,
ये सर कुछ
बोलिए।
डाउट था, ये टेलीग्राम में से डाल दूं क्या? क्वेश्चन था सर।
डालिए ना। Yeah, just put it in the Telegram.
क्योंकि
So what
सर
I will do from starting from tomorrow onwards, I will have a class every day for at least 2 hours until 30th.
यस सर, क्योंकि हम लोग का एग्जाम है सर, 29 को एग्जाम है सर।
हाँ, तो जो doubts है वो आप डालो. Most probably I will be discussing the doubts only. And if that
Yes, sir.
comes in the dry dock topic, तो और अच्छा हो जाएगा. I will cover it with the dry dock topic. I will mix it.
ओके सर।
Yeah, just do that.
ओके सर।
Yeah. Okay.
Yes, sir. Got it.
Yes.
Thank you. Yeah. Okay, sir.
थैंक यू।
Bye.
थैंक यू, बाय।